Okay, welcome back. And now what we're going to do is we're going to discuss the intermediate value theorem, and you want to be careful not to apply the intermediate value theorem or any theorem beyond what it's supposed to be applied to. Okay, so we got to be careful, and we have to understand what the conditions are in order to apply any given theorem, and the intermediate value theorem is no exception. So what does the intermediate value theorem tell us? It says that, hey, if I have a function that is continuous over a closed bounded interval, so that has to be true. If I don't have that, then I can't even apply the intermediate value theorem. And in the case of finding zeros, right, one of the other things too is that the intermediate value theorem says, hey, if I have a function that's continuous over this closed bounded interval, and there's a value in the y value, so some value z between f of a and f of b, then there must exist some real number c on the interval from a to b in the x's, such that f of c equals z. Okay, now, we cannot apply the intermediate value theorem unless we first know that we have a continuous function over the given closed interval. Okay? Also, when it comes to zeros, we have to make sure that we have opposite signs when we're dealing with f of a and f of b, the endpoints. When we test the endpoints, we've got to make sure that we have opposite signs. If we have opposite signs, then yes, we can conclude using the intermediate value theorem that there must be a value of c on the interval from a to b in the x's such that f of c equals 0, right? Okay. So what that means is, what if we have a continuous function over the closed interval and we test the endpoints and we don't get opposite signs for f of a and f of b? Does that mean that there are no zeros within the given interval? No. Okay? No, it doesn't. Okay? It doesn't say that. It's inconclusive. If f of a and f of b have the same sign, both positive or both negative, then the intermediate value theorem is inconclusive. There might be zeros in the interval, there might not. Okay? The only time we can be that the intermediate value theorem is conclusive when it comes to zeros is if you have f of a and f of b have opposite signs. Okay, so that's another thing to keep in mind, specifically dealing with zeros. But let's do an example here. And we're dealing with the function 1 over x. 1 over x is continuous everywhere except where? X equal to 0. So x equal to 0 is restricted. It's not in the domain. Now, if we look at the closed interval that they're wanting us to test, so they're saying, hey, is f of x, is there a 0 in the interval from -1 to 1? So again, make sure you look at the conditions. Are the conditions met to use and apply the intermediate value theorem? In this case, the answer is no, because 0 is in the interval. Remember, the function has to be continuous over the entire closed bounded interval, and here it's not. So we cannot use the intermediate value theorem here. Okay, so we cannot conclude anything about whether there's a 0 in the interval. Okay? And in fact, in this case, there is no 0 in this interval, if you remember the behavior of the reciprocal function, which you should. Okay, have a great day.